So in the last lesson, in the last videos, we talked about factoring and solving polynomials that were cubes, sum of cubes and difference of cubes. Now we're going to move on to quartic polynomials, polynomials that have a fourth power in them. Now we're not done looking at how to factor cubic polynomials. Sum of cubes and difference of cubes are just one type, and not every cubic function is going to have that pattern. So we are going to learn more methods on what to do with other cubic and other quartic polynomials. But there's some patterns that work out occasionally, and so we want to focus on those first because they're easier. So quartic, remember, means 4. Okay, so when you, when you hear quartic, you have to remember that that means 4. So we're now going to be looking at polynomials like this, polynomials that have a 4 as their highest exponent. Now remember, we talked about this. They don't have to have all the terms in order from the fourth all the way down to the constant. And the ones we're going to, and the ones that we're going to look at today are specifically not going to be that, okay? They're going to involve polynomials that are actually skipping the cubic term, okay? Because those are actually fairly easy. And what we're going to be looking at are ones like this, where the x cubed and the x term are missing. And the only reason why this works out nicely is because these are both even. And when they're both even, we can actually relate these quartic polynomials to quadratic polynomials, things like this. And you're going to probably say, well, how does that relate? How can we relate this to this? Well, it involves something that we're going to do with these exponents. If you look at the exponents, you're going to notice that all of these are half of all of those. So we're going to use that idea to help us as we learn to factor these and solve these in polynomials. Okay, so the first thing we're going to do this one step at a time. First thing we're going to do is we're going to learn to factor them first. And we're going to factor them using a quadratic form, okay? Using something we already know how to do with quadratic equations. And then we're going to take it one step further and we're going to solve them. But as long as we know how to factor them, then the rest of it's easier to solve, okay? All right, so when you open up this foldable, you're going to see that the left side is all about factoring them, okay? So let's talk about how to factor these. So if I'm going to factor these, I am going to need to rewrite these functions as a quadratic function. And you're probably thinking, well, how is that possible? It's not a quadratic. Well, it's not, but you're going to see really quickly how it can be, okay? We're going to rewrite it as a quadratic function or a quadratic equation. And we're going to use x squared, okay? Because that's what a quadratic looks like. A quadratic looks something like this, right? So we want to use x squared instead of using x to the fourth, okay? So how do we use that? Well, we're going to substitute a different variable in so we don't have x squared to deal with, okay? We're going to substitute in a value of a every time we see an x squared, okay? So how will I rewrite a quartic equation as a quadratic? I'm going to kind of pause and come back and forth. We're going to do each step one at a time while we do the example, okay? So step number 1 is to rewrite this quartic polynomial as a quadratic equation. What we're going to do is we're going to rewrite every variable using an x squared. Well, that's easy because this one is x squared, right? So that's super easy. But how do I rewrite x to the fourth using the variable x squared? Well, what you should recognize is that x squared can be made into x to the fourth if I raise the power to another power. X squared really means x to the fourth. So if I just, instead of writing it as x to the fourth, if I rewrite it like this, I can basically rewrite this using all x squareds. So I'm going to rewrite this as x squared minus x squared already is in this one, so I'm just going to put it in parentheses because in a minute I'm going to substitute all of my x squared values with an a, okay? But right now I'm just going to leave it there, okay? And then a 4 doesn't even have an x in it or an x squared in it or anything, so I'm just going to leave it as a 4, okay? So all I've done so far is I've basically rewritten as a quadratic equation, and instead of using x to the fourth, I just replaced it with x squared. So all that's in here now is x squared. Now I do have that extra 2 right there, and that's okay. So my second step says to substitute a for the value of x squared, okay? So I'm going to substitute a now for that. So instead of putting x squared, I'm going to put a squared, and then I do have to square it because there's a square outside of it. So that is going to be a squared. Minus 5, instead of this, I'm going to substitute a, and then a plus 4. So all I did was I took both of these and I put an a in their place. The only difference is that this one, if I take away the x squared and replace it with an a, I still have this square that's outside. Over here, I don't. Okay? Hey, that looks like a quadratic equation to me, and we know how to factor quadratics, right? So let's come up here and let's just say that we're going to factor the quadratic. We're just going to use one of our factoring methods for quadratics, which are on page 52 in the notebook. If you want to write that down again, you can. So those 6 methods or 5 methods all involve looking and seeing what we can find among the terms. There's no greatest common factor. It's not a difference of 2 squares because there's 3 terms. It's not a perfect square trinomial because although I can square something to make a squared and I can square 2 to make 4, 2 and a together, when I double them, 2a and 2a don't make 5a. So I can't use it. So I'm going to have to make a t-chart. So step number 3, let's go ahead and let's make the t-chart. Multiply to make 4 and add to make negative 5. Now that's tricky. To multiply to make 4, I would do 1 times 4, and that would add to 5, but not negative 5. So that means that I need these to both be negative, because 2 negatives would still multiply to a positive 4, but 2 negatives would add to a negative 5. So I'm going to want to factor this as a minus 1 and a minus 4. There's my factoring, okay? Okay, so, but that's not really what I had. I didn't have a quadratic equation. I had a quartic. Well, what did I do to make that happen? Well, I substituted the a in for x squared. So now I need to put it back. Now I need to put the x squared back into every place where I took out the x squared. So on step number 4, I'm going to replace the a back with the x squared I began with. And in every one of these scenarios, okay, I'm going to be able to factor them completely. Which means that what I just wrote in there can factor more. Look at those 2 factors. They have 2 terms. If they have 2 terms, they're probably going to be a difference of 2 squares if one is a minus. They might not be, okay? But if they're both minuses, they're going to be a difference of 2 squares. This is a difference of 2 squares because it can factor into x plus 1 and x minus 1. This is a difference of 2 squares because it can factor into x plus 2 and x minus 2. Remember, if it's a difference of 2 squares, they're both made from squaring something and there's a minus sign. If that checks out, then you just write those 2 numbers and you put 1 plus and 1 minus. So this is the fully factored form of that quartic polynomial. Okay? It's a really cool method. It works really cool. It's just kind of neat how it all works together. But it takes some steps and it takes some practicing. You have to practice to get the method down. Okay? Now, in the next video, we're going to now learn how to take this and we're going to learn how to actually solve it. Now, you could do that easily with this one. All of these would be whole factors, okay? Whole number, real solutions. This would be -1, this would be +1, this would be -2, this would be +2. In the next example, when we are doing this, we're going to find that sometimes when we factor, it's going to give us complex solutions, okay? But it may not always.